Now let's talk about naming ethers. So it turns out that ethers are very simple molecules. As you guys remember, the functional group is ROR. And what that means is that since they're very simplistic molecules, these are actually going to be a few molecules that we name with both common names and IUPAC names. Now, if you guys remember, IUPAC names are the ones that were developed after 1919 at the IUPAC convention. That means every name that we have for a molecule before that date is considered a common name. And it turns out that because ethers are so simple, a lot of times we're going to use common names more often than the IUPAC names for them. So let's actually go ahead and start off learning the common way first, and then I'll teach you guys the IUPAC way as well. So it turns out that the common name, the reason we use it so much is because it's very easy to use. All it is that you name the two R groups in alphabetical order, and you end with the word ether, okay? So I'm sure you guys have maybe already started lab, and you maybe have worked with any ether in lab. They have diethyl ether, dimethyl ether. That just means that the two R groups are either methyls or ethyls, right? In this case, this would be a methyl propyl ether, because as you can see, I have an ROR functional group, and I'm just naming the two alkyl groups according to their size. So I have a 1 carbon and a 3 carbon, so that'll be methyl propyl ether. See how easy that is? So most of the time, we're going to use the common naming system for very simple ethers. But it does turn out that sometimes ethers get more complex, sometimes they have bigger branches on one side, and it might be advantageous to use IUPAC. So let's go ahead and see what this same ether would look like if we use the IUPAC convention. Okay? So for IUPAC, what we would do is we would use the same rules that we use for naming alkanes, but we would name the OR group as a substituent instead. So what I would say is, which of my R groups is the biggest one? In this case, I have a 1 carbon side and a 3 carbon side. So obviously, I'm going to use my 3 carbon side to be my root. Okay? And in this case, my root is going to be propane. Okay? So I know that I'm dealing with propane. Now I just have to name the OR group that's attached to it. Okay? And the way that we name OR groups is as alkoxy groups. Okay? So alk just stands for the number of carbons in the chain. So you can imagine that if it was a 4 carbon chain, it would be butoxy. Okay? 4 carbons. So in this case, this one's really easy. I just have a 1 carbon chain attached directly to the O. So this would be considered methoxy. Okay? But now it's not enough just to say that it's methoxypropane, because we know that propane actually has 2 positions. It has one at the end, which would be the first position here. And it also has the middle position, okay? Now you're wondering, what about the last one? What about carbon 3? Well, remember that carbon 3 is the same as carbon 1, because I could always just, it's symmetrical. I could always just put it on 3, and that would just be my starting point, okay? But I have to name the location, so obviously what I would do is it would give my priority to the substituent. So this would be 1-methoxypropane, because it's starting at the first carbon. Pretty easy, right? Overall, ethers are pretty easy to name. Let's go ahead and do a practice example. In this example, I want you guys to figure out what the common name would be and the IUPAC name would be, both of them together, for this molecule. So I want 2 individual names for this same ether. Go ahead and try it yourself.